Hello everyone. If you can hear us, then mostly probably you are very happy to start our workshop Cassandra Data Modeling Methodology. That's Alex Volochnev and David Gelardi, developer advocates at DataStax. And if you can hear us, if you can see us, please set the thumbs up in the YouTube chat so we will know we can start. Hi David.
Yeah, definitely. Hello, Alex. How you doing, bud?
Yeah, it goes very well. I'm happy to be here. You know, data modeling is one of my favorite topics, maybe the most favorite, and I'm very happy to be here and speak about that. And you know what? We already have like almost 100 of people attending these.
Wow, 100 people who want to know about data modeling. What does that say, right? That says actually wonderful things about all of you that are here with us today.
Yeah,
Especially when you're doing data modeling with Cassandra, you want to get this stuff right.
yeah, exactly. So, looks like it's all good and we can start smoothly. It's 6 p.m. and 3 minutes at my place. What's time at your place?
It is 1 o'clock in the afternoon, so
1 o'clock in the afternoon.
not,
Okay, pretty nice as well. And meanwhile, could you please write in the YouTube chat where are you from, people, so we will know where are you from. That's incredible how distributed the community is. Such an interesting time we are living.
Yeah, totally. I see India. I saw Brazil earlier. By the way, Prasanna, yes, we love models. With you on that. France, Lithuania. That's awesome. You know, I'm from Chicago originally, and the town I'm from is actually like a big Lithuanian town. Like all the street names, the church, everything is all Lithuanian there.
That's cool. I
Okay.
didn't know that. And I'm originally from St. Petersburg and now living in Western Germany in the city you don't know. So name doesn't
Yeah,
matter.
right. We've got Netherlands. I see Phoenix, Arizona. Hey, Jay Barnes. I have family over there. As I travel to
Abu
Phoenix actually
Dhabi.
pretty often. Oh wow, San Francisco,
Pretty
Minnesota.
reasonable. Okay, great.
Awesome.
So let's start. We have a lot of things to cover today, so don't want to take too much of your time. Just two words about ourselves. We are developer advocates at DataStax, and our job basically has one main duty: help developers to upgrade themselves. Some people say like upgrade developers. I find it wrong. If person doesn't want to be better, if person doesn't want to be upgraded, better professional, when there is nothing we can change, just nothing. But that's our job, is to help people to upgrade themselves and be better professionals. And that's what we are doing to do today. What's what we are going to do today. Help you upgrade your understanding of a data model for the distributed databases. Our primary thing for today is Apache Cassandra. But the same principles are applicable to any kind of a distributed systems, basically. So then let's start. We have a lot of things to do today. A bit of housekeeping. First, we have a live stream on YouTube. That's mostly probably where you are watching us. And we have a secondary or backup stream on Twitch. And we answer questions and comments on Discord, in our Discord server. You can find it at bit.ly Cassandra-workshop and on YouTube stream. But in general, we suggest to use Discord because YouTube chat is closed as soon as the workshop is over and Discord stays with you, and there are multiple thousands of people there, so you will find someone to answer your question mostly probably. Notice we don't monitor and don't answer questions on Twitch. We want to focus on some reasonable amount of channels. For a quiz, to ask questions to you and then play a game and win some swag, we use menti.com. You may know this system already. It's completely anonymous. You don't have to put your email or anything. You just go and play a game with us and win some swag. And to do homework and to do some practical steps, we use today Katacoda. Katacoda is a great tool. You don't have to install anything. You don't have to make Cassandra running at your place. You just go and use everything in web. So your homework
And
if
you're new
easy.
to us or new to one of our workshops, yes, we assign homework. We assign homework. We're going to make you do things, but you get to earn cool stuff for it, right? So it's worth it. It's worth it for leveling up, and it's worth it for the cool stuff.
Exactly. Okay. And
Oh, don't worry,
before,
Prasanna.
yep,
We'll get you that Menti code. It's coming.
yeah,
It's
it's coming, it's coming. So achievements unlocked. Now so many of you doing great work, participating in the workshops and learning thoroughly and asking so great questions. So we know somehow to highlight you, to help you be visible on LinkedIn, on job market, and so on. So we introduce achievements or badges. We have a regular big certification with exams and things like that. So badge is something kind of smaller, but still valuable. And we are already having people from Cassandra workshops and Intro to Cassandra workshops getting those. Now we are working on the platform to deliver them, and we are to publish them on LinkedIn actually this week. So watch this workshop live or recorded. Do the homework we to call a bit later, and then enjoy your well-deserved badge and publicity a little bit of. For the homework, you will have to do 2 scenarios on Katacoda. It's simple, it's free, it doesn't require any kind of complex installation. You just do everything in your browser. I wouldn't say it's free, David, because DataStax pays for it. We sponsor training notes for you to be able to do the homeworks. So for you it's free and it's sponsored by DataStax. By the way, it's one of the best companies I've ever worked for. So, Cassandra data modeling methodology. Or I better say, how not to screw up with Cassandra. That's very important to understand and to see like how do you make your database not just running but successful. And there are only 2 rules of success: know when to use it and know how to use it. Very simple. And let me check something. It looks like something happened with David and I've lost him. Hey David, are you here? Can you hear me? Oops. Okay, I hope David will join me later. David. Sorry, just a second. And I will proceed meanwhile. Sorry as for this little delay. I hope he will be back with me very soon. So, 2 rules of success: know when to use it and know how to use it. That's the only 2 things you need to know. If you know them, you will be fine. If you don't know them, well, it's really easy to fail with Cassandra. So, when to use it and how to use it. When to use it. Don't be like this guy. This tool is not suited to fix a tire on such a track. You need something bigger, obviously. And my second point here is know how to use it. Otherwise, you will be like this guy. Well, this one is obviously an accident, but I like this peak really a lot. That's exactly how I see people pretty often using their databases. Don't be like that. This workshop will help you to not be like that. And what Cassandra is good for, that's the topic we start. But before that, I want to do something. I have to ask you some questions. Our Menti code for today is 5779, 3515. Or actually, I can just push this button and you will have the code and the QR code on the screen. So you can simply enter this code on the menti.com website or use this QR code to get in. So, let me see you are joining because I want to understand what's your situation, how deep is your knowledge, and maybe there are some topics we have to get deeper with you than others. So please answer my question. That's not a quiz yet because, well, quiz will require some speed from you and you have to be quick, but that's a questions for me to tune up the content. Okay, I see people are joining. That's great. So let's start smoothly. First question, how much experience do you have with relational databases? I mean traditional relational databases, what you usually know as SQL databases, PostgreSQL, MySQL, Oracle, and so on. So everything what relates to SQL. Okay, and I see we have some interesting points here. Most of the people have significant experience with SQL. Some people use it all the time, or big experience, only a little bit, or no prior experience. Okay, that's great to know. Like, so we have some novices here. And then next question. How much NoSQL experience do you have? And I don't mean Cassandra right now, but all the other NoSQL databases, you know, I don't know, Mongo, Redis, some people call it not database, but well, I insist. And all the other NoSQL databases you may call. So we will see no prior experience, a little bit. I use NoSQL a lot. I'm a true guru. Notice like how different picture, nearly everyone knows SQL, but not so many people have significant NoSQL experience. That's pretty cool. And you know what? We are going to change that. The world used to work with general purpose databases, which can be jack of all trades, master of none. Now we tend to use more and more purpose-built databases. Those are specific and dedicated for some purpose and really great in it. No, it really matches the idea of a microservices when you can have different databases for different parts of your system. Good. So, how much, finally, Cassandra or DataStax enterprise experience do you have? Okay, no prior experience, that's fine. Our basic understanding, up to 1 year, 1 to 3 years of experience, and over 3 years experience. I see, mostly no prior experience. So take a look. In general, this workshop expects to you having some understanding of Cassandra. Not too much, but still to have some. I will run through introductional slides in the beginning of this workshop, but frankly speaking, pretty quickly. So please, if you don't have any prior experience with Cassandra, any knowledge of Cassandra, now be very focused in the beginning. I will not repeat basics because we have to focus on data modeling methodology, okay? DSE, Vijay asks, DSE stands for DataStax Enterprise. It's, let's say, kind of enterprise version of Apache Cassandra delivered by DataStax with some very nice features, but we aren't to speak about that today. Good. So, and finally, last question. What about normalization and denormalization? That's pretty interesting. World used to have normalization as a holy grail, and today I'm going to shift your mindset a little bit and show you what normalization can be harmful. Good, so most of you have basic understanding or good understanding, and some are beginners. Don't worry, that's explained in the workshop. So if you don't know those, you will know them after today, which is already a good upgrade. So, we are done. Yes, and finally, I thought it's the last question. How much your work is using databases? I mean, maybe you're a front-end developer which don't work with databases at all, and maybe from another point of view, you're a database architect or database administrator or database reliability engineer which works with databases all the time, like nothing else other than the databases. So that's I want to know. I see most of the people work with databases a lot, or at least some people, or sometimes not too much. Hey, David. David, you are back.
Hey!
Yes, perfect.
Right as we start, my Mac decided, you know, we don't need networks. We don't need to work.
Yeah.
And then...
yeah. I mean, yeah, that's a lunch break for him, I guess. Okay, so we can proceed.
I was hungry. I'll be honest, I was hungry.
So,
hey, Alex, you mind sharing your screen again to me?
Oh, yeah, give me a moment then.
Sorry, everyone.
Yes. Oh, you mean that's a live translation? So there are
Yeah.
always things like that. Start sharing. So you
Yeah, it's
must be
one big
watching my
difference
screen
between
now.
doing these online and doing them in person is in person you can't get rebooted. So there's that.
Good.
Hey, thanks, Alexi.
Yep.
All right.
So at this point, we got all the knowledge we need to have about you, and we are ready to proceed finally. And we see what there are some people with primary duty with the databases, people working with the databases a lot, some people not too much, and 7 people usually don't work with any databases. Well, welcome to the great world of the databases. It's incredible. Basically, you are using databases all the time, just not directly. So, we are done with questions. Don't close the screen because quiz will happen exactly here on the same place when we will proceed. And now I'm switching back to my presentation. So, what Cassandra is good for and what is bad for.
What is it good for? Absolutely everything. Anyway.
No, not absolutely everything. That's the point. You remember 2 rules of success: when to use and how to use. So let's keep talking.
Well, if you know the original song, you wouldn't want me to, what is good for absolutely nothing. So I was just
that's
throwing that in there. But you're right. But you're right, Alex.
Yeah, good. So very quickly, just few words of what is a Cassandra. I'm running through those slides. Cassandra is a NoSQL distributed database. You can have single Cassandra node like you run for your MySQL or PostgreSQL, for example, normally, but usually you run it with multiple nodes. So data is distributed. That's not only distributed, but also decentralized. So there is no thing like primary nodes, secondary nodes, write replicas, read replicas. How we use it to call them: master nodes, slave nodes. Nope, nothing. Every node has the same duties. That's completely decentralized. There is no single point of failure. It's highly available. Nodes together build a data center, also known as a ring. Well, data center ring is the same. Cassandra scales linearly. This plot is not to show what Cassandra is faster than other databases, although it's usually faster. My point here is the more nodes do you add, the more performance do you have. There were a very nice research done by Netflix team and published it in their technical blog. By the way, Netflix has a great technical blog. You absolutely must subscribe to that if you are interested in the technologies Netflix are using. They are using Cassandra heavily. And they scaled their deployment from, like, I don't remember, 20 machines to 350 machines. It was a test deployment. And it scales linearly with no overhead, 0 to very low overhead on adding new nodes. So basically, there are no limits for scaling. Main deployment on Netflix for Apache Cassandra consists of more than 70,000 nodes. And you know what?
Yeah, I was going to say this holds true for thousands of nodes, right? It's
Dozens,
the chart only goes to
thousands,
32,
yeah.
but it goes well beyond that.
Now, that's not a single cluster, but still. But you know what?
Yeah.
You may think, oh, that must be the biggest deployment of a Cassandra in the world, and you know what? It's wrong. We use it to think what Apple has the biggest Cassandra deployment in the world, getting close to 200,000 servers dedicated to Apache Cassandra, and now we know it's wrong because Huawei has even bigger deployment.
Yeah.
So, then, data is distributed. On the right, you see the table of country, city, population. Basically, it's the table of number of citizens per city, per country. In the normal traditional databases, you have this table stored on a single machine, or maybe some write nodes, replica nodes, but Cassandra works differently. In Cassandra, this data is spread, distributed over the cluster. Why? Cassandra is big data ready. Your traditional relational database may work great as long as it fits your use case. What's your use case? As long as your data fits to a single server. When your data doesn't fit to a single server, you have to use sharding. Sharding is a very painful process. It's a manual process, and it makes very, very, very bad things to your infrastructure, your database ecosystem. Cassandra makes partitioning natively from the very beginning. It's completely automated. It's not for you to take care of the data allocation, shuffling data on the servers, adding new servers. You just throw in a new server, you get more nodes, you get more output, you get a capacity, and that's for Cassandra cluster to take care of how the data will be allocated. Data distributed automatically, it's called partitioning, and it's great. That's what makes Cassandra big data ready. But data is not only distributed, data is also replicated. RF you see on the left side is a holy grail of Cassandra, it's replication factor. Replication factor 3, what means what every row, or better to say partition, every partition is stored on 3 different nodes. What makes Cassandra highly available? Then you write some data and you send some data to a replica, then every node responsible for this set of data will get the identification of that. And it works very smooth, but if node is not available, then one who got the request will store this data without a confirmation. Oh, I see my node is not responding for whatever reason. I will store hinted handoff. And as soon as failed node reports recovery, okay, colleagues, I'm back online. Sorry, what did I miss? Then node what got the request dispatches the hinted handoff back, and the node recovers completely, so there is no missing data. Well, Cassandra has a lot of self-defense mechanisms. Yeah, David.
Yeah, exactly. And I was just going to add to that, which is this mechanism that Alex is talking about, right, for hints and the self-healing mechanisms of Cassandra doesn't just apply to individual data centers, right? This actually applies across data centers. You could even have a case where you have multiple data centers, and if a whole data center went down, which we've seen in some major cloud providers in the last so many years, that whole regions get lost or whatever, as requests are coming in and one of the other data centers is taking over that traffic, they will also store hits for that other data center. And when that thing comes back up, it'll get that, you know, back in sync as well. It'll heal it up. And one other question I just want to hedge off, because we almost always get it. Should you use any RF less than 3? Unless you're just messing around with like a quick development test environment, a single node or something like that, no. Stick with 3 or more. Really, 3 is the sweet spot. 3, by the way, the standard, as Alex said, the holy grail of that holds whether your cluster is 3 nodes or thousands of nodes, right? You can do that and have a very nice balance between availability, consistency, and performance with RFA 3. So just use 3 unless you have a good reason not to.
Yep, and there is a good question. What happens when multiple nodes fail? It depends on on your settings. So when you run a query, you must specify consistency level. It has default settings, so you don't have to when it will use default setting by default. But you can have specified a consistency level, desired consistency level. And if you have replication factor 3, you may say, I require consistency level 1. So even single 1 answer will be enough to me. So this way your data being dispatched, stored or written or read, even as long as one single replica is available. But it may bring to some troubles. We discuss it later. And then second point is then you can specify consistency level quorum, which will require to be available majority of your nodes. And then you will need at least 2. And if you have replication factor 3, 2 nodes are down, then cluster will answer desired consistency level can be reached. I have only 1 node, you require 2 to be available. So there is a problem for you to handle.
So Alex, I do see a question or a set of good questions coming in. And 2 of them are related with regard to, do you advise having nodes across regions or zones? And that was from Vijay. And then Bennett said, can you require that replicas are all in different regions? So you can totally put your nodes wherever you want, right? Now, here's the caveat, right? Is you want to ensure that nodes that are in a single data center, at least geographically speaking, because we're talking like speed of wire, speed of light, you don't want to put them so far away that there's going to be a lot of latency incurred between the nodes. However, you can totally distribute nodes in a single data center across, say, multiple AWS regions or multiple cloud regions. And yes, that's a good practice, right? And I think given what we're talking about, the folks who are asking that are probably asking, well, hey, what happens if a cloud provider goes down in a region? I want to protect against that. Exactly. Yes, that's a great idea. So just make sure, though, that you're not doing it where you're setting up a data center where you have nodes that are all the way in the West Coast and the nodes that are all the way in the East Coast or something like that in the United States. It's going to be too much latency. But you can either do it in small regions, small geographic regions in a single data center, or you can have multiple data centers that are in those further apart geographic regions and facilitating kind of the same thing. So the answer is definitely yes, you can spread them across regions just fine. I think you already answered Nikhil's question. Is it the same as like having a quorum? Because you talked about quorum. From that standpoint, let's see. Sirhan, does the failure risk of frequency increase as the RF increases? You know, that's a neat question, really.
That's a good question.
Yeah, go
That's
ahead,
a really
Alex.
good question. I mean, in general, more nodes, more servers you have, higher chance what some of them will be down. If you're having 2 servers or you're having 2,000 servers. If you're having 2,000 servers, there's a pretty high chance at least one of them will be down at some point. That for us, that's not about failure risk frequency, but more about the answer, possible answer delays. Take a look. We have replication factor 3. We execute a select statement with a consistency level quorum. It means 2. So we will wait for 2 answers. So, and there are always some possibility of network latencies. As far as we use majority of 3 nodes, 2 nodes, we only get 2 fastest answers, and the slowest one will be then, we don't wait for it. It works pretty quickly. But when you have, let's say, replication factor 100, you will have to wait for 51 responses. And that's why we don't recommend to have replication factor 100.
Right.
Because there is much higher chance to run into latency because you're just waiting for a bigger group. But you know what?
And then...
Yep. David?
Oh, and if you take an example, if you have a replication factor of 100, and then I am trying to achieve a consistency level of quorum, that means in order to achieve that consistency, I will have to get an acknowledgement from 51 nodes, right? So you can see there's definite diminishing returns as you just simply increasing replication factor doesn't answer what you need. And that's actually why we say replication factor of 3, even if you have thousands of nodes, is the standard. It is the sweet spot. You don't need to increase your replication factor heavily in order to get the benefits that you get for like availability and such. As a matter of fact, again, if you increase it too much, as Alex is pointing out, not only will you increase a lot of latency, but now you have to wait for all of those nodes in your consistency when you go to read and write and such.
Yep. Now, last question I answer before we proceed, because those are questions for Introduction to Cassandra workshop, and that's data modeling workshop, so we have to proceed with some respect for those who came for data model. Then, last question I answer before we proceed. Cassandra works on AP mechanism as per CAP theorem. Sorry, Biswajit, it's a not correct statement. People say what Cassandra is AP from CAP, but that's not technically correct. Cassandra is configurable. Switch consistency level to O, boom, you are CP, but not AP. So that's configurable.
And that's configurable
Cassandra,
at the query level.
Yep. Cassandra is configurably consistent, not eventually consistent, actually. So we are happy to answer your questions. Please, let's discuss it after the workshop in our Discord, okay? So...
Yeah. Keep your questions coming in the chats, and I'll try to answer them without saying it in voice.
Yep. Now, that answers question asked for cross-cluster replication. Not cross-cluster, but cross-data center. One single cluster may have multiple data centers. You may have data center in the United States, Europe, China, and they all will work as a part of the same cluster simultaneously. And you specify replication factor per data center. So you can say, for my data, for my application, I want to have 3 replicas in the United States, 5 replicas in Europe, and 0 replicas for China, because this application, this part of my application just doesn't work with Asia, so I don't need data there. So I will save some time and money on the data replication and disk space. Also, Cassandra is completely platform agnostic, so you can run it on the Microsoft Azure, AWS, Google Cloud, on-premises data center, whatever you want to have simultaneously. So you can have the same cluster spread over multiple clouds. And that's really cool. So it's completely platform agnostic. That's a very good and very powerful technology which you can run everywhere and don't depend on any of them. Today you need your data center, Microsoft Azure. Here we go, you are welcome. It's easy to organize. Tomorrow you aren't satisfied with fair pricing policy anymore. Boom, you can easily migrate to another cloud. So that's actually really, really cool and no vendor lock. Now there is one incredibly important limitation to understand, and a really small amount of people working with data understand that. There are, let's say, one line with two endings and some databases in between. Some databases tend to the left, some databases tend to the right. It's called OLTP or OLAP and OLAP. OLTP stands for Online Transaction Processing, and OLAP stands for Online Analytical Processing. What does that mean? OLTP workloads tends to have highest requirements from the time point of view. You want to open, I don't know, a profile picture of your friend on Facebook. You want to see this profile picture right now. You don't want to wait for an hour. You need it now. That's typical for OLTP. That's why it's called transactional processing. So how a high amount of the transactions. Then it tends to run more or less simple queries. Like simple queries is maybe not the best explanation, but queries don't change to be 1 kilometer long mostly, so they tend to be easier and simpler. And queries don't change too often. I mean, every application develops over time and business requirements are changing and your queries are changing as well, but that usually happens within weeks, months, or years, not many times per day. And on the other side of this line, we have OLAP, Online Analytical Processing, which is different. Answers can wait, like my analytical team works with this database. They're getting salary for what they're doing. They can wait. Queries tend to be sometimes very complex and including getting data from the very different pieces of your system to bring it all together. And queries tend to change. Today you have to realize, I need the list, I want to make a marketing campaign, I want to send an email to all of my subscribers, all of my clients from the last year who did at least one, who has bought at least something from a car, things, I don't know, whatever they could be able to buy for a car, some car tires, for example, and did at least two operations, two purchases from a category, I don't know, beauty and style, and exactly these sizings, and then you can construct a query and get some data for this. But tomorrow you are looking for completely different data. So queries tend to change all the time. And that's comes about analytics. And which kind of databases we use it to run all the time. Traditional RDBMS are in the middle. You can have some kind of OLTP transaction processing with them. And Cassandra is different. Cassandra tends to be strictly on the transactional processing side. What does that mean to us? Cassandra is very good when you need your answers now, very quickly, right now. No wait, milliseconds, microseconds, right now. I want to use simple queries because joins are slow, joins are not scalable, and I need to have a simple query. Denormalization, we will speak about that later. And queries don't change too often. And if your system, if you have requirements, so you aren't so much into fast answers, but you are going to run complex queries and they will change all the time, then Cassandra may be definitely the bad choice for you. Or better to say, Cassandra is not enough. Usually you have mix of things. You need a little bit of OLTP, you need a little bit of OLAP. And in this case, we can speak about the teamwork. For example, Apache Cassandra is a perfect integration with Apache Spark. and then you can have them together running and successfully executing. Cassandra will be on the OLTP side, Spark will be on OLAP side, able to answer whatever the query or data you want to retrieve, but not so fast as Cassandra, of course. It's really hard to keep the pace with the Cassandra. Good.
Yeah, Suhan in Discord, or I'm sorry, in YouTube says it perfectly. You can't have them all. You can't have it all in one database. And
yes.
I completely agree with that. Yeah, there are trade-offs, and Cassandra takes the trade-off of being like super fast at scale.
Yeah, exactly. You can have them all, but not within the single database. Basically, that's what DataStax Enterprise does. You have Cassandra, you have some additional tools, and then you have both OLTP and OLAP. Yeah, but not within the single tool, but within a platform. So then, so what the main features for Apache Cassandra? Big data ready, highest possible availability, geographical distribution, extreme read-write performance, vendor independent. Those are the sweet spots of Cassandra. If you see this list and you know like, okay, my project needs all of these, then you definitely need Cassandra. If you see this list and it doesn't touch you, like, okay, my project may be not really ready for that right now, we don't have such high requirements, then you have to think on the next two lines I'm adding. Cassandra requires qualified engineers, and Cassandra is OLTP specific. So if you are the only one working on a small project, single region project, and you don't expect to have billions of clients from all over the world, then Cassandra really can be a bad choice for you. Because, well, you need to have your own team of database engineers to keep it running, or maybe then you have to consider DataStax Astra, and you already have those engineers supporting your Cassandra automatically. Via DataStax, we run Cassandra as a service. That may solve this problem, requires qualified engineers. But if you want to run it on your own, you need to understand. And again, that's OLTP specific. Fast queries, simple queries don't tend to change too often. And you know what? There is a little very nice consequence. More and more companies are growing bigger and bigger. Amount of data grows tremendously. By the year 2025, amount of data, digital data on the world expected to be more than 200 zettabytes. And that means world needs a lot of data engineers and people able to work with the most powerful databases in the world, which is Apache Cassandra. And therefore, learning Cassandra technologies, you are able to get better and better salaries in the best companies over the world. Netflix, Instagram, Apple, and many others, they all use Cassandra because at this scale, you need something extremely powerful. So, use cases. When to use Cassandra? Everything what relates to scalability, availability, distributed platforms, and cloud native. You say cloud? Okay, Cassandra is able to distribute your data and keep your replicas on different availability zones automatically. You don't even have to set the replication like I want to have one replica in availability zone 1, second in availability zone 2. Cassandra knows it and does it for you. So that's really cloud native. You want to have global presence. Here we go. You can have cloud, you can have your data centers in any places of the world. Mission critical. There is basically no database more available than Cassandra, as long as you cook it right, of course. So it's still shared responsibility. Cassandra gives you the tools, but that's for you to use them. And then finally, scalability. Cassandra scales linearly and able to handle any amount of writes and read as long as you have enough nodes. And if you don't have enough nodes, then throw more nodes, give more nodes, and it will be able. So, good. If this part was a too quick run for you, that's perfectly fine. I see we have a lot of people with no prior knowledge of Apache Cassandra. We do Cassandra related workshops every week, and we did intro to Cassandra only recently, and we will do it again very soon. So in general, I suggest you to just watch the recording of the last workshop, do your homework, get your badge, and be a better engineer. So that's great. Now, hey David, are there any questions
Yes.
regarding first part you want to mention right now before we proceed?
I think, yeah, I think that I got most of them in the chat here. There's one I'm actually answering in Discord, saying most of the times teams complain of repair being slow when the key space grows inside. Anything that can be done to improve on that? And I was answering that. One of the big things I actually see, I realize this is more on the Cassandra standpoint, less on the data modeling. But one of the big things we see a lot are cases where folks aren't actually running repairs or running them regularly at all. And then they decide they need to do it one day and they're like way behind. So one thing is to ensure that you're running them regularly. There are different types of repairs. There's things like incremental repairs. You don't have to do a full repair every single time. You can also control, it does help if you think about it, repair is going to be working, if the underlying partitions themselves are getting bigger and bigger and bigger and they're unbounded, they're not controlled, then that is also going to have an impact. So it's good to keep your partitions. I think we're actually going to talk about that a little bit later. Keep your partitions within practical limits and stuff to help that as well. I don't know if Alex, there's anything else you want to add.
Not to this one, but there are 2 points I want to mention also. I see from questions on YouTube. Are joins possible in Cassandra? Asked by Dharani. I already answered it in chat, but I want to explain. Joins are not only not possible in Cassandra, they will never be possible intentionally for a very simple reason. The main principle of Cassandra right now, extreme performance on data of any size. And your joins may work more or less fine as long as your data is on a single machine. But Cassandra is what? Distributed, decentralized. What it means to us, joins don't scale. And as long as joins don't scale, they are just awful on the distributed systems. Can you have joins on the distributed networks? Yes, you can. It's possible. But when you have to forget about any kind of a performance. As soon as you you are going to have join on the distributed environment, forget about milliseconds. And Cassandra is all about right now, so no joins. Second point from Pranithar Kamara. My team said you have to unlearn normalization to get more understanding of Cassandra. And that sounds great, but I think we can upgrade this phrase a little bit. When you learn SQL and when you learn databases in a university or in a practice, everyone says normalization, 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 normalization. They give you the sword, this holy sword of normalization, and whatever you do with a normalization. And you know what? Normalization is great. Normalization is really great. And for many of my use cases and tasks, I use normalization perfectly. But what I want to give you something except of this sword, I can give you, I don't know, a crossbow. And there is a place to use sword and there is a time to use crossbow. And this crossbow is denormalization. So this one is to upgrade you and make you able to understand and use those tools in the different places. There is nothing holy in the normalization. That's just bad when you use it on the wrong time in the wrong place. Sometimes you need a gun. And the denormalization can be your gun for many of the projects. So, relational for normalization, NoSQL for denormalization. Let's take a look. What's the normalization, first of all? Database normalization is the process of structuring a database in accordance with a series of so-called normal forms in order to reduce data redundancy and improve data integrity. It was first proposed by Edgar Cott as a part of his relational model. That means what you tend to write every piece of your data only once. Basically, every name, like name of the department, can be mentioned only once in your database. And if your engineer works in the engineering department, you will have two tables: departments, employees, and foreign key relation from engineer to a department. And that's how normalization works. Deduplication, reducing data redundancy. Normalization is great. Normalization gives you very powerful things like simple write. If you're going to rename your department, you have to execute only one query, which is cool. And it also gives you data integrity, all the foreign key checks, all of them on delete cascade, and others and others and others. So normalization is great. But everything comes with a price. And price for the normalization. Slow reads, because you have to use joins, and joins are slow, and on big data, joins are extremely slow and not always even possible. And complex queries. A question I ask all the time. I believe there are people from yesterday workshop. There are some people from yesterday workshop who know the answer already. I kindly ask you to stay quiet, but please tell me, write answer in the YouTube chat. How many joins you can have in a single MySQL select statement. So select blah 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 from blah blah blah, join. How many joins you may have in one single statement? Graph, very close, not correct, but very close. Maybe something has like bigger limits, smaller limits. Hey Cedric, you know the answer. I asked you to give the chance for people to ask, but yes, 2 digits. Correct, 2 digits. Answer is 61 indeed. And how do you...
Gaurav got it, yeah.
And answer is 61. Answer is, how do you expect your select statement to be quick if you are using dozen of joins? Okay, it's a rare case to use 61 join, but well, I've seen it in my life. And how do you expect your query to be quick? And how do you expect your query to be quick over hundreds of servers? There is basically no way. So that's the price of the normalization. Let's move on. Sample relational data modeling. You create entity table, you have the constraints, you have index fields, and you actively use foreign key relationships. Yes, Vijay, 61 join in a single statement. Yes. Don't ask me. So that's how it usually works. You can have all nice things, so like create index, constraints, email, unique, and so on. You have relations. That's because they're relational databases. And SQL, Cassandra query language, is different. Joins don't scale, and we need to work with a big data. So we cannot have any joins, and we can have very limited aggregations. When you handle petabytes of data, you cannot have quick aggregations anymore. It just also don't scale so well. So, speaking of the relational data modeling.
You know, here's a question, Alex. From Vika. Did that system work? The one with 61 joins?
Yes, very slow. And you know what we did to handle that, David? You know what we did to handle that? Denormalization.
True. Yeah, isn't that the way? In anyone who's ever done any data warehousing here in the relational world, what did you do to speed up queries? Denormalization, right? That's the whole point of denormalization is to speed up your reads.
Yeah.
You know, so we'll talk about that a little bit later, actually.
Yep. Good. So then relational data modeling. How it usually works. First, you analyze raw data. You identify entities, their properties and relations. You design tables using normalization to deduplicate the data, to remove redundancy. And you use foreign keys to link the data to establish data integrity on delete cascade and so on and so forth. When you use join, then doing queries to join normalized data from multiple tables, and then read performance getting bad, you apply denormalization as an inevitable evil. But that's what I want to say. Denormalization is not evil. Denormalization is fine as long as you control that. Yes, that's a dark side of the force, but it's still a side of the force you can learn. We aren't in a Star Wars movie. You can have both, and you should have both. So, denormalization is a strategy used on database to increase performance. In computing, denormalization is the process of trying to improve the read performance of a database at the expense of losing some write performance by adding redundant copies of the data. You see this table on the right. Before, if we needed to retrieve data of our engineers, we needed to do select and join. And joins are slow and don't scale too well. And now we have table employees. And if I want to retrieve data of my Edgar Cott, I just need, I will get my engineering as a part of a single select statement. Simple queries. You see, remember OLTP uses simple queries. Benefits of this: quick read once, and simple queries, easier to maintain. Have you tried, okay, not 61, but have you seen queries with 10 joins, 15 joins? It's really hard to maintain them. And with simple queries, those easier to maintain. But again, that comes with a cost. So dark side of the force have some requirements. Multiple writes. Now your data is denormalized, so you need to keep it under control, and you have to update all the pieces of your data spread over multiple tables. Now that's on the application side, and basically it means on the developer side. You know what? I'm fine with that, as well as I'm getting paid for that. And well, Cassandra enabled people are usually getting pretty decent digits, let's say, in their salary. And then finally, manual integrity. We have to sacrifice data integrity, or better, move control of the data integrity from the database layer to the application layer. Okay, so applying denormalization brings us to combine table columns into a single view, eliminate the need for joins, and queries are conscious and easy to understand, but there is still price to pay for that. Denormalization in Apache Cassandra is absolutely critical. And the biggest takeaway is to think about the queries first. We will speak about that in the next steps. Again, there are no joins in Apache Cassandra. Queries in relational versus NoSQL databases very simply explained in this slide. In a relational database, one query can access and join data from multiple tables. In Apache Cassandra, you need to query data in the different way, and sometimes it goes to up to one table per query. And that sounds awful, and well, indeed, it brings a lot of complications. But when you do handle again billions of rows and petabytes of data, that's the only way for you to be able to dispatch them within milliseconds. So what's about the modeling queries then? We need to understand what are your application workflows. You need to know your queries in advance is critical, because your tables are dedicated for your query. Query is the queen, query is everything in Cassandra world. And that's different from the relational databases. I cannot use join, and well, I can create an index to support new queries, but indexes over distributed data, again, painful and have some downsides. We don't speak about indexes today. And yes, it can be up to one table per one query. When we speak about workflows for Killer Video is our demo application we use to show how do we work with Cassandra. It's kind of YouTube, you can say, so also videos, users, comments. If you know YouTube, you'll consider yourself knowing Killer Video. And speaking of the design of our tables, you need to understand the query. And what's important for us is queries are not random. Queries are based on the workflow. Queries are based on what you are doing on the database, what you are doing on the application. Which application you use it today before the workshop, think about that. Mostly probably you will log it in. When maybe you open it your profile. You did some basic operations. Every operation involves one or more queries, at least definitely. You send a message to your friend. Hey, I'm going to attend a workshop about Cassandra. It's going to be cool. Join me. That includes query, or maybe two, or maybe more. You know, denormalization requires multiple write. I'm not so bad about that, because point is I execute them simultaneously, so it doesn't require too much time. Writes are very cheap and quick on Cassandra. Cassandra is ready to devour any amounts of write you execute. And then speaking of the use cases, on how do you use your application, YouTube or Killer Video, you get from the user operations, basic user operations, to the queries you are going to do as a result. User logs into the site. What we are going to do? Find user by email. Pretty obvious. User opens a video. We have to show comments for a video. Find comments by video. We know video ID. We have to show comments. Ratings. We need to show ratings for a video. We have to show basic information about a user. So we have to find user by ID. Then user wants to see his recent comments and reactions, likes, dislikes, and so on. We need to find comments by user latest first. So NoSQL data modeling goes in the opposite direction. You don't start with analyzing your data. Well, you do, but we will see very soon how it works. But you have to think a lot about the application, or people say, think of application. I say, think about people, like humans first. It's not about software or hardware. That's about people. Let's think about people first. Analyze people behavior. What are they going to do with your application? What will be your particular workflow? Log in, find a friend, send a message to your friend. Okay, that sounds good to me. When we identify those workflows, their dependencies and needs, and define queries to fulfill those workflows, knowing the queries, design tables using denormalization, and then use batch when inserting or updating denormalized data of multiple tables. Now we will get deeper into that, so don't worry. Cassandra data,
hey, Alex.
Yep.
Yeah, Alex, before we move on, if you could go back to the other one, back to the previous slide.
This one?
Yeah, just something I want to point out. Yeah, that one. And we're gonna get to the fun one, the pop, right, later on. But you know, for those of you who are familiar with this, especially coming from the relational world, right, you start with as developers, we usually we're given the schema, right? We're given ERD, we're given that, and then we use that to generate our queries. This is kind of a paradigm shift right here, right? What Alex showed is the little bit of a paradigm shift because it's in our control. So instead of us as developers who are coding these apps having to reference somebody else's schema and look at, okay, what tables do I need to join? How am I going to make my query? We are the ones who then actually generate what the data model is going to be, right? And it's actually in our control. So it's a little bit of a paradigm shift, but it's really powerful at the same time. It also it seems like it would be the opposite. It doesn't seem like it would be freeing, but you'll find this methodology and the way that we go about data modeling in Cassandra, once you get the process down, is a lot easier to get going. And there's a lot less constraints. But anyway, I'll let you go on there, Alex.
Yep. So I see I hide some information on this slide. Sorry, Vikasni. Okay, what was the question? James Vasanath can't read the words on the bottom left. It's a use batch when inserting or updating denormalized data of multiple tables. Cool. So, Cassandra data modeling. It all starts with a cell. And when we go to a row, and then we finally go to a partition. So everyone understands the cell and the row and the column. That's simple. Thing we have to remember is a partition. Data is partitioned. Partition is a base unit of access. If you don't know your partitions, you aren't going to be successful with your queries, because every query should understand its partitions and how data delivers. Then data of the table is a group of columns and rows storing partition. Overall, our structure is key space contains tables, and tables contains partitions with column data. Example data on users organized by city is going to be just very simple as that. We have key space, which contains multiple tables. We have table, which contains rows and columns. We have partition key columns, which defines the partitioning. We have clustering columns, which define sorting order within the partition. And we use data columns just to store data. And we have partitions, therefore, based on the partition key columns. Creating a table in SQL is very easy. If you know SQL, this statement must look very familiar to you. we are to create table killer video users by city within the key space killer video, table users by city, some column definitions, city, last name, first name, address, email, all type text. Don't worry, we have more types, not only text, but more data types. And when we define primary key based on the partition key and clustering columns. Primary key is identifier for a row. It consists of at least one partition key and 0 or more clustering columns. Partition key is the one what defines the partitions. So based on the partition key value, data will be partitioned, therefore split it into multiple partitions. Clustering columns are needed to ensure uniqueness within the primary key. So, for example, this sample is bad because our primary key to user will be city, last name, first name. And can you imagine how many of John Smiths we have in New York? I remember it's at least 15 of them or something about that. And as Cassandra is a NoSQL database, it uses upsert, so insert or update depending on the situation. Basically, every next John Smith will overwrite the data of a previous John Smith, which will make the first one unhappy. So we use email here to ensure uniqueness and to have primary key unique for this one. Then, sorry, I have to interrupt myself, but there is a great question I have answer for. How do I unlearn defining foreign keys? Very easy. You go and do practical steps on Katacoda with me. So you will see how we do it very soon. Again, I'm running through those steps because we expect you to have some understanding of Cassandra. So I'm repeating that quickly. If you don't get enough into that, you have to watch Introduction to Cassandra workshop where we go through it slowly. So, rules of a good partition. Partitions are very important. If you don't do your data model with a partition right, you will run into troubles inevitably. You need to know how to use your tool to be successful with it. First, store together what you retrieve together. In this example, when you open a video, you see comments for this video on YouTube or on killer video, it doesn't matter. It makes sense to partition your comments by video, so all of the comments to the same video will be stored together, and then you can retrieve them with a single simple network operation, not requiring looking for my comments all over the cluster, which is called full cluster scan, which is obviously very slow. So store together what you retrieve together. In this case, I retrieve together comments for my video, and therefore I use video ID for those comments as a partition key, so they store it together. Then, rules of a good partition. Second, avoid big partition. You don't want your partitions to be too big. Why? You remember why we are doing partitioning? Because at some point your data don't fit into a single server. In general, the idea is the same. Even with partitioning, you still can have too much data for a single server. So, there is only one hard limit, up to 2 billion cells per partition. Cell means columns multiplied by rows, very simple. That's only one hard limit. Others are recommendation. Not more than 100,000 rows in a partition, not more than approximately 100 megabytes-ish in a partition. What does that mean? Those are recommendations. For example, for my video and comments table, I'm not afraid to have bigger partitions, more than 100,000 rows in a partition. You know what? On YouTube, some videos may have much more than 100,000 comments. But that's not a problem to me because this data is small. Basically, it will be video ID, comment author ID, date time, text. And those are small. What would it be? Some kilobyte? So it's not so big deal for me. I'm not afraid to have more than 100,000 rows in a partition. But there is something to consider. Next point, which is very often a mistake, like very common mistake, constantly growing partitions. If in the beginning I partition my data for my IoT, a lot of sensors reporting their state from all over the world, reporting it all the time, every 10 seconds, and I design my table like that, partition by sensor, and clustering column reported at, so they will be sorted by time. And the data is very simple: sensor ID, timestamp and a value, temperature, humidity, whatever you want to have. This schema, will it work? Answer is it will for the first few months. And then at some point my partitions will be too big and it won't be so efficient after all. So what I may need to have here some bucketing. Bucketing is a very important idea. I'm basically introducing a synthetical column here, month year, integer or a string, it doesn't matter. And my partition key is now composite. It consists of two parts, sensor ID and month year. What is a month year? Very easy. Now it's merge. So basically it's 03, 20 to 1, merge of year 2021. As soon as merge is over, within 1 week, this partition will be closed. Well, like not really closed. You still can force put some data into that. But the month changes. Next month, year will be 04 to 0 to 1. And therefore, new partition happens. And then partitions are never grow too big. As soon as month is over, you are automatically having a new partition. Very simple. So, and finally, avoid hot partitions. What does that mean? With big partitions, if some partitions are big and some partitions are small, you will have uneven data distribution. And some of your servers will have 5 terabytes of data and some of them will have 5 gigabytes of data. That's obviously bad, but that's not the hugest problem. Hugest problem is hot partition. Then some partitions are being accessed all the time and some partitions are not. If it leads to uneven data distribution, imagine you have a data center of 10 servers and you have replication factor 3. Every partition is replicated 3 times. And you have one partition being accessed all the time while others are idling. It means that your 3 servers will be overloaded and others 7 are idling. And you know what? You can try to use elastic linear scalability of Cassandra and add 90 more servers. Upgrade from 10 to 100. It must give you some performance boost. Should it? Or maybe should not. The problem is you still have replication free. You have your data on 3 servers. Even if you have 100, 1000 data in the same data center, it doesn't matter. You will have 3 servers overloaded and all the others, now 97 servers idling, just because you have had bad data model. So monitor your servers, monitor your partitions, avoid big partitions and avoid hot partitions. That's what really matters. Some people may say what in my video and comment, it may be the bad idea also creating hot partitions, because you know some videos are being commented all the time, like our stream right now, but some videos aren't commented too much, like some not popular videos. Then it happens what this video is being commented and my partition in the comments is hot, and second one is not being commented and my partition is not hot. That's not the problem, because I have a lot of videos and those are evenly distributed over the cluster. This way, my data is spread over the cluster and all servers are busy in more or less the same way. And when I throw more servers, when I upgrade from 10 to 20, data will be reshuffled to more servers, and every server will be responsible therefore for smaller amount of partitions, and performance pressure will decrease. That's very important to understand about the hot partitions. It's fine to have loaded partitions as long as they are evenly distributed over the cluster. So, how Cassandra organizes data? We have here example of the library. You will see in a moment with replication, network topology strategy. So the one replication you use on production. And for data center west, we will have replication factor 3. For data center east, we will have replication factor 5. And we have a table here, create table library, then use by year, with year, name, country, and home page fields, and primary key of year, which is a partition key, and name. Okay, and we are going to have two tables: artifacts related to the event we run, and venues by year for those events we are having. Let's take a look at some things. Based on the data we have, notice venues by year are organized with a partitioning based on a year. Therefore, for every year I run, I will have a single partition, and that's thus my data is spread into multiple partitions. And they are replicated based on the replications. For key space, I set here, for my key space library, I set DC West 3, DC East 5, and my table venues by year relates to the key space library. Therefore, those settings will be applied, and data is spread 3 times in the data center West with replication factor 3, 1, 2, 3, 1, 2, 3, and 5 times the same data in the data center East, as those data centers working together in a single cluster. With Cassandra query language, we have 2 parts of it. It's separated into 2 parts. Data definition language, DDL, and that's all about creating and manipulating schema. Create key space, create table, create index, create materialized field. But also we have data manipulation language, DML, which is must be very familiar to you with select and insert, update, delete. So when we create tables, we need to think about some very important points. Definitions for us: create table, whatever name we have, column, type, and it's possible to have it static. I will explain it in a moment. With primary key, with at least 1 or more partition key and some clustering optional keys. And also we can additionally establish clustering order by ascending or descending, because we want to store data in ascending or descending field. When things we are thinking of all time when creating table: table name, names, types, and possibly static designation for columns. Partition key must have, clustering key optional, and row ordering in the partition if we need to set up it with clustering order by. Now, if you have experience with SQL, you understand most of that, but there is a question what static means. Always comes. Explanation is very simple. Do you remember my example with videos and comments for the video? One person may write a lot of comments to the video. That happens. And as we use denormalization, every comment record in the table of the comments will have video ID, comment ID, user ID, but also username. So we don't have to execute any 2 select statements. And all of them again written by the same person. In this case, I may call the column type static for the outer of a comment, and it means what this value of this column will be the same for the types of the partition here we have. In general, static is helps you to have a single value per partition, and when you want okay, video example maybe not the best here, but we will work on it a little bit later. And when you can easily change it with a single one statement. Sorry. Well, partition can be single row or multiple row. What's the idea here? Simple idea. With single row partitions, I use a unique partition key. Absolutely unique. Every person in my users list will have universally unique ID. Universally unique ID looks like that, and they will be unique, obviously, and therefore I will have as much partitions as users I have. That's perfectly fine. But also we may have multi-row partitions, and multi-row partition is very simple. Now we have here venue and here, and what does that mean? All the artifacts will have the same partition, will be within the same partition as long as they share venue and year. So we have here DataStax Accelerate year 2019 and Data Modeling Zor year 2019. But so those make the partition. First partition, second partition. But artifacts, we can have multiple rows within the same partition because artifacts for this table will be different. And country, in this case, is indeed the static value. It's shared by all the rows of this partition. So if I update this value and replace it from USA to the United States of America, just renaming for whatever reason, I need to execute this statement once per partition because all the rows of this partition are sharing this value. Good. So SQL select and things we need to know about that. Idea of a select is simple. You want to retrieve some data. And first you have to specify some selectors. So select what? Columns, aggregation, functions, including user-defined functions. When from table name, and we can have only one table per query, no joins. When where, we may have primary key conditions, and that's important, an index condition. And now notice, restricted to primary key columns. Remember I told you, Cassandra is not for every use case, but you may need a whole platform serving your data. Do you remember we have partition key, clustering, column, data columns. What does that mean? You cannot use data columns in your where statement. So in this case, we have primary key, venue, year, and artifact. And venue, year, and artifact, we always have to specify the full partition key, and we can select by artifact. But as long as title is not a part of a primary key, I cannot use it for searching data. So in this case, title is a data column, and without using secondary indexes, I cannot search by it. You will see how to handle it very soon, but that's important. Search conditions are limited to primary key columns, partition and clustering. Group by only by primary key columns. Again, order by clustering key columns. Limit, okay, that must be clear. And finally, allow filtering. And there is
Don't do it.
Big red field danger. Yeah. What's the allow filtering? Allow filtering. So let's take a look. I want to retrieve data from this table. And I know I'm looking for artifacts. I am looking for talks from DataStax Accelerate we did in year 2019. When I do my select statement, select everything, whatever I need from DataStax, from table artifacts by venue. The venue is DataStax Accelerate and year 2019. And I get the whole partition and I'm fine. Why? Because driver of your application, Cassandra driver you use to retrieve data from Cassandra, is extremely smart thing. As soon as it starts up, your application startups and connects to Cassandra, it will load the whole information about data, schema allocation of your cluster. And you need to get some data. You give select venue DataStax Accelerate, year 2019. Then your driver executes a partitioning token calculation, and it already knows schema allocation, and it knows which exact node IP address to ask. So it don't go to this node and ask, do you maybe have any information about DataStax events in year 2019? Or maybe, you know, sir, with 100 servers, it will take ages. So your driver knows which node to ask. And that's really cool. It's just one network operation. Every node is able to answer every question. Because if node has this data, it's able to answer. And if node doesn't have this data, it will work as a coordinator node and it will ask replica nodes. Whereas no problems.
Yeah, and,
you will get
and an example I like to use in this particular case is the food delivery example. So imagine you have a city, which many of us live in, that have millions of people, right? What's more efficient? Is it more efficient to say, take your food delivery and go directly to the address of where that food delivery needs to go? Or is it more efficient to just start at some random house and just start knocking on each door next door and going, is this your food? Is this your food? Is this your food? So essentially, if, like what Alex was saying, if you are trying to query outside of your partition key using something like allow filtering, you're doing the latter thing. You're actually just knocking on the doors until you find the data. That's why you have to scan all that data. It's much, much more, like orders and orders of magnitude more efficient to just go right to the address, right? So never, ever use allow filtering ever. And I'm not going to shame anybody. It's okay if you didn't know this before, but if you're using it in your queries now, you seriously need to stop. You need to take a look at your app. You need to take a look at what you're doing. You need to stop using them immediately, because you can get lulled into thinking you're okay, because at small scales, small amounts of data, allow filtering will seem to do just like what you think it should. But then as that data scales up and things, it's going to come down to its knees and you're going to have problems. So that's my allow filtering rant.
Yep.
Don't
exactly.
ever use it.
So if you don't specify a partition, you make your food delivery guy to knock to every door of the building.
Yeah.
And if you have a huge building, it will take ages. So Cassandra has a defense mechanism from that. If you aren't specifying partition key, for example, on where statement, then therefore you will have nothing, you will have no answer, just an exception. Can do that, don't make it do it, it's stupid. I don't want to have it run. If you insist, you can say allow filtering, and it will lead this query to be executed. But it's very harmful, and don't run it on production.
No, God, no. So by the way, Alex, before we continue on, there are just a slew of questions that have come in. I've tried to do my best to answer all of them, but everyone's asking so many wonderful questions. And by the way, if we don't answer your question right away, we're watching. Don't worry. That's what I'm going to do right now and come back to them. So I just wanted to come back to a couple, if that's okay with you, because they kind of hit on some of the things we've been talking about. And I'm trying to be respectful of time here. So one from Dyson over on YouTube is, why can't the common ID be used for sorting? It can. You can use common ID for sorting, but think of what a UUID is. And so in Cassandra, when we talk about IDs, and by the way, there were a set of questions around IDs. In Cassandra, we don't use generally, you can, we don't generally use integers for IDs. We use UUIDs. Why is this? Well, if you think about it, Cassandra is a distributed system, right? So if I have multiple nodes that then, let's say I have two writes that are coming to insert the same user at the same time somehow, right? Or even two different users, but I want to generate a UID. Now, what happens if I network, I sever my network connection and these two nodes can't communicate, right? Then if I'm using an int, then what's to stop me from getting two users who now have ID 5, right? Whatever the thing was. And then now the network comes back, they can talk, what's going to happen? Well, last write wins, so the last one's just going to overwrite the one before it. So that's not a very protected way to use IDs in a distributed system. So Cassandra uses UUIDs. Now, going back to that point, those UUIDs are going to be nice, sign-ins and stuff, and they're very long. The chance of you actually getting a repeat on one is infinitesimally small. But the point being is, going back to Dyson's questions, why can't common ID be used for sorting? Well, you technically could. You can make it a clustering column, but how do you sort on a UUID? Sorting on a UUID isn't going to be very effective. So if you were thinking about it, I'm trying to read your mind a little bit, Dyson. If you were thinking about it from an int, you're like, oh yeah, I could totally sort on that, right? But if you're thinking about it from a UUID, it's a little bit different. Again, when you add it in a clustering column, it will naturally sort it for those types of values that can be naturally sorted. Let's see, James, I know you've been asking this question and I wasn't ignoring you. It got buried and hadn't gotten to it. An upsert happens only when all of the clustering column is matched or when a partition key is matched, right? So the upsert is going to happen if you match exactly in your primary key, right? So if you've got, that's the thing that defines a unique row. So that could include your partition key and clustering columns if you have them. But the key thing is off your primary keys. So once, if you have an exact match to a row, then yes, you will just upsert. Let's see. There were a couple others here. There were just so many. And again, wonderful questions, by the way.
Yep. I'm afraid we have to proceed because, well, there were wonderful questions, but we still have some topics to cover.
That's fine. I will. I got some of them out, and I will do the rest in chat as much as I can.
Yep. Thank you. And just one thing, VJ asks, so when to use allow filtering? In short, never. In short,
Never do it.
Moreover, don't allow your colleagues to use it.
No.
Include it into your code style quality checks. Include it into your continuous integration. That's funny. So basically, if you don't have code review, if you don't have code style quality checks, including, for example, these allow filtering things, one single junior software developer of your team, if you don't watch what he is doing, he doesn't know Cassandra, he just wants things working, he executes select, sees what it doesn't work, goes to Stack Overflow gives a bad advice of allow filtering, he puts allow filtering into select statement works, he is happy, ticket is closed. Cool. Things just got much worse, because if this code goes to your production, you are deep in troubles and your cluster productivity may be heavily affected. So you have to hunt down, you have to follow and exclude any kind of allow filtering you may find in your project, literally by just checking your code. So let's move on. We have more things to discuss still. Sample SQL statements, we partially discussed it on this table already. Maybe select all from artifacts by venue. The venue equals something and years equals something. This will work because, well, we specify a partition key. And venue equals something, year equals something, and artifact equals something. It will work because we specify a partition key and clustering column. So, and finally, the venue equals something, and year equals something, and artifact more than, and artifact less than. It's still fine because we have partition and clustering columns, but let's take a look at something wrong, some things what won't work. Select something from artifacts by venue, where venue equals something. What's wrong with this statement? Don't remember, to avoid full cluster scan, we have to calculate the partition token. Partition token in this case will consist of two parts, venue and year, but we give only venue. It won't work, we cannot calculate hash based on only one part of a key. So yeah, James, very right, only one key, that's wrong. Where venue equals something and artifact equals something, will this work? Nope. We don't specify year, which is a part of partition key, which basically brings us to the same situation as before. Where artifact is more than and artifact is lesser than, we don't specify partition key at all. That won't work. Where venue equals something and year equals something and title equals something. What's wrong with this statement? We have venue and year, so we have a full partition key. Partition can be calculated. But I cannot sort and I cannot search by title, because title is a data column. And then finally, where country equals something, which is again, we just don't specify the full partition key. So, very important implications for data modeling you have to remember at all times when doing data modeling for Cassandra. Primary keys define data uniqueness. Partition keys define data distribution over cluster. Partition keys affect partitions and therefore partition size. Clustering keys define row ordering within the partition. And with query, primary keys define how data is retrieved. Partition keys allow inequality predicates, and that's important. Partition keys allow only equality predicates. I cannot make it more than year 2019 or less than year 2018. Why? Because it's inequalities, and partition keys support only equality predicates. You can have in, so where year in 2018, 2019, 2020. Because it's still not inequality, that's still equality also from the range. So this will work. Clustering keys allow inequalities predicates and ordering. Only one table per query, no joins. And finally, we come to the main topic of the workshop we are doing today, Cassandra data modeling methodology. Sadly, I have no slide, but I want to mention what data modeling methodology was developed by our colleague, Dr. Artem Chibotko, and that's a big honor for us to have him in our team. So let's get to the process of how exactly do you design your tables. And in general, the idea of data modeling is here pretty simple. We have to collect and analyze data requirements. We have to identify participating entities and their relations. It's a no-relational database, but we still have to understand relations. We have to identify data access patterns. It sounds very scientific. Sooner I get simpler on that. Particular way of organizing and structuring data, designing and specifying of a database schema, and schema optimization and data indexing techniques. So then if you are to make any screenshots or photos of your screens, that's exactly the moment you have to do it, because that's the main slide of the workshop. Cassandra data modeling methodology is basically very simple. You need to understand the data, identify access patterns, apply query first approach, and optimize and implement physical data model. So we go to understand the data with a conceptual data model. And that goes to entity relational diagrams. We have to understand our data. If we don't understand our data, there is a very low chance we can produce something good. But also we have to identify access patterns, or easier just use cases, workflows, how exactly people are going to use our application. And that goes with application workflow diagram. When we map them together as a first transition, and as a result, we get the logical data model. We describe this model using Chibotko diagram. And then we apply second transition. We optimize logical data model, and we get physical data model. Again, and we get Chibotko diagram on a physical level and CQL already, so statements to execute and create. That works in the very simple way. Designing process step by step. Conceptual data model, application workflow, mapping, getting logical, optimizations, getting physical. And for our sample, I will use YouTube. Very easy, everyone knows YouTube. You're mostly probably watching us on live on YouTube right now, or maybe not now, not live, but still. And I can say also thank you so much for the warm comments you are leaving, all the thank you guys, hear you next Wednesday. That's always exciting, and it keep us focused, keep us happy, and help us produce more and more content about the things we are going to do. So we will work with videos, and specifically with video comments. And first thing we need to understand again is a conceptual data model. So we use entity relationship diagram, and that's on your screen. That's what we have right now, conceptual data model. The data we are going to use is user and video and comment. Video can be commented by user, and user leaves comments on the video. And that's many-to-many relation, because one user can comment many videos, and one user can have many comments for the same video, and one video can have comments from multiple users. Every user has some properties, email, ID, some others, we will skip them for now. Every video has ID, title, description, and others, and comment has some relations to user. One comment has only one author, and to a video, one comment relates to only one video. That's simple. And it has obviously timestamp and text. Simple as that. So I believe in general this idea must be very easy, because, well, it's a user writing a comment on the video. I don't want to stop for too long here. Second step, what's our second step? Application workflow. We need to understand application workflows. And here comes something interesting. Some of you may be now like, okay, comments, videos, that's pretty clear. Why do you use it as an example? It's too simple. If you are thinking it's too simple to be an example for educational purposes, let's see what you will say after those slides. We have to remember of the use cases. We need to understand application workflow. And we have two use cases here. First use case, it's actually second here, but it's primary use case we want to cover. Someone opens a video page, like you have a video page, open it right now as you listen to me. And therefore, you are going to get some comments for this video. So that's a use case. User opens a video page. And let's think of a workflow. We need to find comments related to target video using its identifier, most recent first. Sounds simple so far. But that's not the only use case we have. We have a second use case, which is first on this example, sorry. User opens a profile. Which user, which profile? First, there may be some spam reports on some particular user, and as a moderator, so user stories, yes, as a moderator, I want to see all the recent comments of a suspected user to make a decision to delete his comments or not, to ban him or not. That's the first case. There is one more. I can open my own profile to watch my own recent comments and see my recent comments and their likes, dislikes, answers, and so on. You see, those are the same basically, because let's take a look. Find comments related to target user using its identifier gets most recent first. It goes both to me as a user watching my comments, but also goes to administrator or moderator watching my comments. So basically we have two workflows here merged into one because they are technically the same. So we discussed conceptual data model, user, comments, video. We discussed application workflow. I want to open a video page and see the comments. I want to open my profile and see my comments. Now we map them together to get what? Mapping process. I'm start to think of the queries. So query is the queen, query is everything. I think of queries, which particular query I will execute to get something. Find comments posted by a user with with known ID, most recent first. Query second. Find comments for a video with a known ID, most recent first. And that brings me to the idea comments by user and comments by video. If you are too much in the relational, of course you are, that's why you are at this workshop, you are great, thank you so much. So you may think, why do I think of comments by user, comments by video? Why can't it be just comments? And the answer is, I basically cannot execute those statements to the same table. Why? Let's take a look. In the comments by user, I know user ID, but don't know video ID, because I want to get all the comments by user as a moderator or as in my profile, so my own comments, but still I know user ID, I don't know video. And in the second point, then as a user of YouTube, I open YouTube video and I want to see all the comments. I know video ID because I selected it from a list, but I don't know user ID who wrote that. And therefore comments by video. You see, for this one, video ID is a partition key. For the video ID, I need to have it up and running, and I need to comments to be already grouped into something. And for user ID, I need comments by user distributed and partitioned based on the user ID. And that comes us to a question. There is one entity, comment, but two tables, denormalization, no joins. Downside, as always with denormalization, we have data duplication. If user writes a comment, we have to write it into two different tables. And if user edits his comment, if it's allowed in your system, you have to make 2 updates basically. With batch, it's easy, but we will discuss batch a little bit later. What happens then? Idea is very simple. We need to have 2 tables. Positive point in both queries, in both use cases, we will need no joins, and even over thousands of comments, query can be executed very quickly, asking one particular server we know responsible for this data. Good, and I see question about arrows was answered already. Up and down is the sorting order of the column values. So that's our logical data model, comments by user and comments by video. And then as a final step, we are to get physical data model. And going from logical to physical, we are applying optimizations to make our tables simpler. Take a look at the logical data model. In the table comments by video, which parts of a primary key I need to have. Video ID will be my partition key. That's pretty clear, to make the partitions based on video. When I need creation date, why do I need creation date? To have sorting based on time. But then that's not enough. Imagine I do not have here comment ID. Imagine I have only video ID and creation date. That may lead to a problem if 2 users write the comment in exactly the same time. Second one will overwrite the first one. Primary key must ensure uniqueness. And when we have to add comment ID to a primary key, because well, otherwise it will be unique. Same for comments by user. We only have user ID instead of video ID. And now we apply very nice optimization, call it time UUID. The trick is Cassandra supports time UUID, which is at the same moment of the time. Universally unique ID, this long string, which is universally unique in the universe. And meanwhile, it's a timestamp. So they are sortable. You can sort your UUIDs by time. So that's very convenient. You can extract date from it. And you don't therefore to have 2 values here for comment ID and created at. They are not needed. Your comment ID already has created it inside, and it's sortable, and it's really cool. As a result, that's how our table looks like, and that's our physical data model in Chebotkov diagram. And finally, that's our query for schema definition language. We have create table, if not exist, comments by user, user ID, UUID, comment ID, time UUID, video ID, UUID, comment, text, primary key, user ID, comment ID, with clustering order by comments ID descending. So I will have my recent first. And basically, same goes to comments by video thing. That's how it works. And that's the whole process. So let's walk once again from it through all the steps we just did. You remember? First, you understand your data and create entity relationship diagram. And you identify access patterns and create application workflow diagram. Then you map them together, apply very first approach to get your logical data model with Chebotkov diagram. Then you optimize them and implement optimizations, getting physical data model. And as a result, you have physical layer Chebotkov diagram and SQL. So that's how it works step by step. And that's what you do designing your data model. And now you know what? We are getting close to the end of our time. So now we will do 2 things. Actually, that's what you will do on your own. And we will run the quiz. So homework, don't forget to get your workshop upgrade complete achievement badge. You need to do homework. And first thing for us to do will be order management data. I send you a link in a moment. So with well, link is on the screen, but I want to copy paste it in the chat. It's at datastax.com, learn data modeling by example, order management. That's a great example. It's about tracking orders and their statuses and doing updates. Actually, I believe I have it right here. So yes, I will send the link to you right now. That's a part of our homework. Please don't do it right now because we are running quiz in a moment. That's the link to it. And oops, sorry, it's linked to a wall topic and I want to have order management. So that's my guy, order management. Very well. So that's the right link. And David, could you please?
Yes.
Nikita, thank you. We will be, could you please copy paste it to Discord?
Yep.
And that's the first part of the homework. In short, order management data you will do as a part of your homework. It's a very simple idea. This diagram looks special, like it looks big, but actually it's very simple. Just don't get too much into the details. Yes, you will implement it, and yes, we helped you, and yes, with Katakoda and our support, it's really easy, even though it maybe looks like not so easy. We are going to have users, shopping carts containing items, and order based on the shopping cart has order status history and delivery options and some addresses we are going to use to deliver. So it's that looks daunting, but don't be afraid of that, because again, that's all prepared, and now you have to follow our steps and think why it's happening exactly this way. So we already did analysis for data access patterns and entity relationship diagrams. We thought of the logical data model, how it would look like from our point of view. Maybe your idea would be a bit different, and how physical data model would look like, and how finally you can apply it. Idea of the link we sent to the list, we sent to the YouTube chat is first. I actually let me move it a little bit and show it to you. So I hope you can see my screen. The link I sent you explains the very things we are doing, why it works this way. We describe application workflow. We explain logical data model. And finally, when it's all done, there is one very important thing. To put your hands on it, don't be just theoretical. You need to put your hands on that. You need to push the button, start scenario. And then you have your scenario started. You use the Katakoda integrated on our DataStax.com website. And you have real Cassandra running there. And then there is a simple idea. You can just execute statements from the left side, read through the things we are doing, make your experiments, and then do some of your own tables and see how it works. So I can just push the button and get my results here. Key space created. I use this key space. I create table, but that what you have to do is to walk through it, read that and see how it works and try to change something. That would be the best one. And then finally, then all the things are defined. When you play a little bit with all those statements, here comes the real homework. Now you have to design queries to execute those statements and to retrieve the data. We have to select something, find all orders placed by Joe, find all information about order, but also we have to design updates, so cancel order. And because we are having multiple tables, how do we cancel order? You always can use a solution here which explains what particular operation we have to do, but in general I ask you to try to do it as much without the solutions as possible, because that's what upgrades you as a developer for real. Good. So let me move back to my slides. And last few things you may need to know before we proceed to the quiz. Update statement will look very familiar to you. Update statement is simple. But there is one cool thing which may help you a lot in your operations, which is called lightweight transaction. We explain them more in our workshop, but now you need to know what they exist. Lightweight transaction help you to define if conditions in your updates, inserts, and other writing statements. So, for example, if not exists, usually Cassandra does not do read before write. If you want to store something, you will get an upsert. But if you want to avoid upsert, if you don't want to insert data if row with this primary key exists, then you can go to if not exist lightweight statement. Cassandra will execute read before write, and you will get notified what this statement wasn't executed. And second statement, we want to mention what you need to know, and they aren't part of this workshop, but you need to know about them to design these, to use successfully those applications, design these applications. Batch statement help you to execute multiple statements to different tables updating the same data. Batch helps you to have multiple statements within single batch. Cassandra batches do not have rollback. Once again, there is no commit rollback. Begin batch, apply batch, that's it. There is no rollback mechanism. Why? Because transactions like that are slow and distributed transactions are extremely slow. So batches don't support rollback, but there is very low to zero reasons for Cassandra to fail applying any kind of them insert statements. If your CQL is not valid, batch will not be accepted. And if your CQL is valid, there are no data integrity checks. There is no operations like that. It just gets it and puts into the table. Basically, I've never seen any batch fail it, or if it fails altogether. Good. And basically, we are ready to go to quiz. I know what we have much more answers, questions when we can answer right now. But I see Cedric and David are doing great job. And I see most of the questions are answered. If we were not able to answer your questions, please find us on Discord or community.datastax.com. And now I'm about to switch to quiz. So I see we have almost 100 viewers on YouTube. And therefore, I want everyone to be able to participate in our quiz and answer questions. Don't forget, if you joined us too late to answer the first questions, it's fine because quiz is just starting. Please go to menti.com and use the code 57793515 or scan this QR code and you will be able to participate in the quiz. Now, speed matters. Speed is the key, so you have to answer quick enough, otherwise you cannot be on top of the competition. But that's important to give correct answers as well, because, well, that's we accept only right answers. I see almost 60 people joined us already, so I give 5 more people time to join and we start. We are almost out of time for today, so just 5 more. 61, I see. 62. Okay, 3 more. 3 more and we start. 2 more, 2 left. 65 and 66. Okay, let's start. Then quiz time. Now we are going to answer fast to get more points. So answer fast to get more points. A key space, what is a key space? Is organized into rows and columns, contains tables and set replications, is the base unit of access, is a place to store extra house keys. Sorry, James, no music today. I will set up it for tomorrow, I swear. Thanks, David. That was good. Good. So, correct answer is key space contains tables and sets replication. It's not the base unit of access partition, but it's organized into rows and columns. No, it contains tables and sets replication. And let me see the leaderboard. So, who was the fastest one? Who was the fastest one? Like a lot of correct answers here. And Bill gave the fastest answer, good result. And we see a lot of people here with very, very good results. So just some minor points difference. That was first question, ladies and gentlemen. So let's see what's happening next. Question second. Answer fast to get more points. What is a partition key? I hope this one will be harder. An optional column to allow group by. A column to define partitions required. Required column to set sorting order. The key to all the doors. And time is up. So most of you have answered correctly. A column to define partitions required. That's a correct answer. And let's take a look at the leaderboard. Did any of the leaders made a mistake? Okay, no mistakes, but now we had some difference in the performance. Not Alex is the fastest. Hey, that's definitely not Alex. Alex, you see my arms here. I'm not typing answers, so that's not me. By no chance it's me. And Casper second on the second place and Pavel on the third place. Very good result. But a lot of things will change. We still have 6 questions. So let's take a look. Question 3. Answer fast to get more points. Table can have many rows per partition. True or false? It requires special Cassandra YAML configuration. It's illegal. That must be illegal. David, what do you think?
I don't know. I think you could probably get arrested for that. If you,
Yeah. You can have many rows per partition, but don't forget, don't go too much, because too big partitions or too hot partitions are bad for your cluster. So, and what's happening on leaderboard? Oh, Pavel was a little bit slower this time, so I guess there will be some changes. And not Alex is still fastest. Hey, what's happening? And Casper 2 holds the second place, but Vas get to the top 3. Congratulations, that's a really great result. And Pavel and Steele in top 10, so a lot of things may change.
Oh yeah, I see Dyson. Dyson's been answering or asking all sorts of questions, and I was like recognizing the names there.
Question 4 of 8, and we are getting to the middle. Answer fast to get more points. In Cassandra tables, which are required? Data columns, clustering columns, or partition keys? Hey, David, do you like requirements?
Oh, I love requirements.
Well, I'm not so much with you at these questions, sorry. But you know what? Doesn't matter. So, they give you some time to think, because for beginners it may be complex question, but actually only one of those is really required. And correct answer is a partition key is required. You cannot create Cassandra table without specifying the partition. Clustering columns are optional. They are important. They may be required defining on your design, but only partition keys are truly required, and definitely not data columns. So, what's going on here? Okay, hey, who is that not Alex? What's going on? Casper and Vas are holding the second and third places. Great job, everyone. So, question 5. Let's move on. Answer fast to get more points. Inequality predicates are allowed on all table columns, partition key columns, clustering key columns, no inequality predicates are allowed. Time is up. So, clustering key columns. You cannot have inequalities on partition key columns. You have no predicates on data table columns, so all table columns don't fit. And no inequality predicates are allowed. It's wrong because clustering key support inequalities. So, are there any mistakes in the leaderboard? So, Casper and Vas are here. And there are some changes on the second part of a board, and Dyson gets to a 4th place, which is a really good result, and there are some minor difference in points, like 50 points. That's nearly nothing. Dyson, Mufasa, JavaDev definitely have chances to get to the top 3. So keep fighting. We have more questions.
Yeah, and I have it on good knowledge that the person there on the top might be cheating. So.
Yep. So, question number 6. Answer fast to get more points. In the data modeling methodology, we start modeling with physical data model, with logical data model, with conceptual data model and application workflow, with copy-paste from Stack Overflow. Well, okay, that's what I usually do. Copy-paste from Stack Overflow. Just add some allow filtering and it will work, you know. So, correct.
Yeah, oh my God. No, Alex. No, you didn't say that live. No.
Yeah, that's brutal. So, in the data modeling methodology, we start modeling with conceptual data model and application workflow. So, entity relationship diagrams and application workflow diagram, those matter for the beginning. Most of you have answered it correctly. It means we did our job well. And it looks like some people are gone. That's completely changes the board, how it looks like. So, Dyson, that was a true jump to the top 1st place. And Soma gets to the 2nd place with the fastest answer, which was enough to bring him or her to the 2nd place. And Mufasa is dead. Oh, such a name, such terrible name. I'm almost crying. Mufasa is dead on the 3rd place, and Skits is ready to fight to get to the top 3. And Jay Barnes is also very close. Good. So, let's take a look. We have 2 questions left. And question 7 is going to happen right now. Answer fast to get more points. Primary key defines row uniqueness. False. Correct. Primary key is deprecated. It should have been for ages already. So people are answering and time is up. And correct answer is yes. Primary key indeed defines row uniqueness, and that's the main duty of a primary key. Primary key may also define sorting order based on the clustering columns but it's optional. What's really important duty for primary key is to define row uniqueness. And it's not deprecated. Aren't going to happen anytime soon. So, leaderboard. Who was the fastest and what are the jumps? JavaDev was fastest, getting to the place number 5. Mufasa is dead, is on the 1st place with Dyson on the 2nd, with only 10 points difference out of 6,290. That's a great result. And Mr. Barnes is on the 3rd one. Congratulations, very good. Xaveras and JavaDev, keep fighting, you are close. And Soma, you have chances. You do have chances. So don't give up. That's the last question. Question number 8. So, answer fast to get more points. That's your last chance to change things in the leaderboard. How does Cassandra perform joins? Cassandra joins require a join table. Exactly like SQL joins, Cassandra does not support joins. Cassandra only joins clubs. I would say Cassandra joins developers from all the world. Take a look, people from all the world are here. Ah, Josh, yeah, thank you. Josh Barnes, I remember you from the last workshop, I believe. Yes. Great! Cassandra does not support joins. And I see some people answer it just like SQL joins, and it scares me. For half of the workshop, I believe it was Fat Fingered, because half of the workshop we were saying Cassandra does not perform joins. Okay, so thank you so much. I hope you enjoyed this workshop. I think we are done for today. Thank you for answering our questions. Thank you, David, for joining me. I think it's a good time to stop the translation, and I'm going to enjoy my dinner. Work is done. What? I forgot something?
Alex.
Okay, if you insist. So, leaderboard. And yes, so tight, point to point, with so minor difference. Dyson
See,
gets
not Alex was
back.
the fastest, but Dyson did it. Awesome. Oh, James Barnes, look at that. Jay Barnes got up there.
Yes, Jay,
Cool.
it's Josh. Josh Barnes made it to the top 3. Congratulations.
Woo!
Well done. And Dyson is on the first place with 7,245 points. That's a great result. That's a very good and quick answers, and no answer failed. 8 correct answers. Some of them were not so fast, but it's definitely all the correct answers. Mufasa is dead is on the second place with difference of 10 points. That was around 1 microsecond difference between Dyson and Mufasa. And Josh Barnes on the third place. So those top 3 make the leaders of today's quiz. And you do deserve some prizes from DataStax. So as Jack Fryer wrote in the chat, Dyson, Mufasa, and Josh Barnes, please contact Jack Fryer at jack.fryer@datastax.com to claim the prize. Remember to send a screenshot of your Menti screen, please. Yep. Yeah, and I remember Josh indeed participated yesterday and ended on the second place. So welcome to the top 3. I think it feels good. It must feel good. Now, if you didn't land on the top 3, still, if you're on the top 10, great result. There are many dozens of people competing with you. If you see your name on the list now, you did great. And if you are not in the top 10, you know what? Prizes we sent. I mean, yeah, that's cool. There are some nice t-shirts and cups and whatever we sent. Ask Jack. But that's not the main point. You still can come to the next workshop and earn your prize. What matters, really matters, is the knowledge you acquired today and skill you will work on and polish during your homework. And as a result, it gives you incredible chance to be better engineer, to be better developer, administrator, or whoever you are. As a result, be better in the field you're working on. Get to a better workplace, get higher salary, and enjoy more of what you are doing and share your knowledge, and as we are doing right now. And that's really great to see you here. We enjoy this workshop as much as you do, hopefully.
And the homework, by the way, the homework is designed to really gel in all the things that we talked about today. So we really encourage you, separate from the badges you can get and all that, we really encourage you to go do the homework. It doesn't take that long, and it's going to really help solidify all your knowledge.
Yep, and regarding DJ's question about Josh Barnes' workshop, yesterday we got a different workshop with different topic, so it isn't really helpful for this one. So, how do you like this workshop? You spent over 2 hours with us today, so I hope you liked it a lot, and it looks like it's correct. Now, thank you so much for the feedback. We are happy to answer your questions, and they are happy to joining you. By the way, regarding you are happy with this workshop, do you see this gentleman to the right from me? His name is David Gilardi, developer advocate at DataStax. Directly under him, you have a like and subscribe button. And that's a very good moment to hit this button, both like and subscribe, so you will get notified by YouTube by our next stream. And then open question. What's your feedback? What did you like the most? What was not so exciting? What would you change? Which topics we have to cover in the future? That's an open question, and you can write multiple questions. You can write multiple messages here. Menti.com 57793515. Show top 20 next time. Oh, I'm sorry, we cannot do it because it's Menti, it's a third-party application. We just don't know for real. We have no button to do it. Keep up excellent work. Thank you sometime. Topics were almost the same as yesterday. Yesterday were more about the Cassandra basics, and today more about data modeling. But I can agree, and there are some things for me to change in this workshop. I agree. Add music.
Yeah, and to that, we do, for some of the workshops, except for like advanced data modeling, we don't go into any of the Cassandra basics. We just get right into it, right? Because it's a different workshop. For something like this, we kind of present some of the basic Cassandra fundamentals for people who are brand new. So it just depends on the workshop, right? But maybe some stuff, like Alex said, for us to adjust in the future.
This workshop was super. More soon. We are doing workshops every week, sometimes multiple times per week. So thank you so much. And yes, more workshops are coming soon. There is a link in the YouTube chat regarding how to subscribe to the next events.
Yeah.
And take a look, David. Where is it? You did great. David was too quick to answer most questions. My database is slower than him. That's incredible.
That's why I was so quiet, actually.
Yeah.
Like, you guys were asking, everyone was asking such wonderful questions. Like, some of them are really solid, and I had to like, and I was trying to keep up. My fingers are bleeding over here. That's funny.
Yep. Great. Now, get it back. Workshop is not done. Workshop is not done yet. We need to do some things, speaking about the homework. So,
yes.
For the homework, what we are going to do. So let me switch a bit. Where was it? Yeah, okay. Just a moment. Yes, here we go. So,
and by the way, while you're bringing that up, Alex, I just want to point out, everyone, please take a note of the links that Jack is dropping in. Those are really important for you because those are free giveaways. That's separate from the swag.
Yeah.
Somebody asked about Cassandra certification earlier. You can totally get a voucher free, a voucher for 2 free tries for your Cassandra certification. Those are $145 a piece. So we're giving those to you for free. Or there's a $300 Astra credit in there. So even though Astra will roll over at $25 a month, which is good for like small production workloads, completely free. Right, that's something that you just get for even using it. But you get a $300 credit for doing nothing more than just creating a database in Astra. It takes like a couple minutes. That is good enough to run an actual production workload for months, like many months. So it's your choice, right? So make sure that you are getting that form from Jack so you can get free money from us.
Exactly. So, wrong page.
Oh, James is asking, what do we get for completing the homework, Alex?
Yeah, so I'm going to ask, first of all, don't forget about the voucher. Don't forget about the certification. Exactly as David said, you can get a free course on Cassandra at the academy.datastax.com. academy.datastax.com. And with a voucher, you can pass the certification for free. Well, it's not free, but it's sponsored by DataStax. So DataStax covers that, and you don't have to pay anything. Learn and pass the certification completely for free. It's incredible. And it can be your first certification, even if you're a student. So when you will be finishing your education already as a certified Cassandra developer or administrator, basically at the academy.datastax.com, we have all the courses related to Cassandra, things we are doing at the workshops, but much bigger, because, well, Cassandra is not so simple topic. We are getting most of the basics now. Now, next point. Grab the voucher, it's safe. Now, for the homework. Workshop is not over. You have to do homework. First thing we do is Cassandra data modeling. Give me a moment. Wasn't it here? Nope. Was not here. Oh yeah, that's it. I found it. Good. So that's the first link you have to do. Absolutely, it's prepared by our colleague, and it's really great. So Steve Holiday, thanks to him very a lot. He put a big effort into that. So first thing is this one, Cassandra data modeling, the basics. Then second thing we have to do is the one I've shown you briefly. Where is it? Where is it? Boom, not here. Data modeling by example. I got a link, I've just lost it. Where is my data modeling by example? Sorry for the delay. Data modeling, here we go. So, order, not this one. Okay, lost it again, sorry. Yeah, data modeling by example, that should be this one. Great. So, in the data modeling by the example, you can choose any you like the most. There are 7 examples. We work to add more. If you're more interested into the shopping cart, okay, like e-commerce, we have shopping cart data modeling. If you're more interested into the messaging, we have messaging data modeling. Particularly interesting examples, simple, but also very important to understand. Sensor data modeling, and more upgraded one is time series data modeling.
Yep.
And finally, the one I was talking about is order management data modeling. So I'm inserting the link here. Oops, I was to copy paste the link. Yes, copy link address. Good. Don't forget to do the practical part. There is when you finish the theory, there will be a button. Boom, 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 boom. Start scenario. Here comes the practical magic. So you do the statements. Please share the links. I'm sharing links in the YouTube chat. There are 2 links already. That must be enough.
Yep.
And as a result, you just simply need to submit the screenshots of a complete scenario. There is a nice, fun, fancy page like scenario completed. Then you start scenario, do the steps, you have the scenario completed. So basically you need to submit at least 2 scenarios completed. How to do it? Very easy. Add me on LinkedIn. Again, link is here. Link on the YouTube chat. Add me on LinkedIn and send them as a message. We are to establish the platform what you can use a form. For now, we are working on it. It's not yet delivered. So please just catch me on LinkedIn and it will work for you. Okay? If you have any questions, find us on Discord, bit.ly/Cassandra-workshop. And basically, that's what we have for today. Homework, Cassandra data modeling and order data management, or sensor data modeling, or maybe you will like to do more, then that's great. Developer resources.
Sorry, Alex, real
Yep.
quick. James is asking, I thought create Git issue.
Yes.
I know that we did that in the past. Are we saying the LinkedIn is the new way, or Git issue still?
You see, a Git issue is great, but
no
the only point, we don't have a Git workshop.
Yeah, we don't have a repo for this one.
We don't have a repo for this one because you do all the practical step. Maybe do you think we need to create a repo? Basically, it will be empty, just the slides.
I would say, yeah. So to answer that, James, you're correct. For other workshops where we do provide the Git repo, then yes, you can have a Git issue. But I would say for this one, why don't we stick to what Alex you just stated and send it to him over LinkedIn?
Yep. So for this one, you get a LinkedIn page, and we tag you on LinkedIn and promote you as our workshop achievement complete, achievement unlocked, and your Cassandra upgrade complete for data modeling workshop. Good. So materials: hands-on learning and datastax.com/dev. Ask a share at the community.datastax.com. Follow us on YouTube, Twitter, Twitch, and so on, and more materials are coming on the our places, and Discord is very important to us. Main place for us for the learning is datastax.com/dev or academy.datastax.com. They are different. Yeah, LinkedIn is the easiest way to contact him. Then, thank you. We are done for today.
There we go. And I'm just providing, popping some of the links down here for folks in Discord. There we go. All right, that's it.
Thank you. Great. So, thank you. So many questions. It looks like you kept David busy all the time. I only would hearing David clicking, like your fingers must be bleeding.
Yeah, I need to, I'm not going to show my hands this time because you don't want to see it. It's too gruesome. But yeah, I'll have to get that fixed.
Great. Okay, and again, don't forget to ask questions on Discord. And see you again soon. Don't forget, we run every workshop 2 times, on Wednesday and on Thursday, for different time zones. And we will happy to see you in the next one. That was David Gilardi from the United States, Alex Voloshev, well, from Europe. And thank you so much for coming. See you next time.
Thank you, everyone. See ya. Bye-bye.